Hey, today we're also going to go over 6.2, and 6.2 is very similar to what we covered in 6.1, but we're going to do more real applications, that normal distribution. Kind of the difference really is going to be that if you remember from 6.1, our standard deviation was 1 and our mean was 0. And in this case, our standard deviation will be numbers that are based on the problems that you have. And so to me, it's a lot more of they talk about the real applications of this one, and which I think is so true because this one we're going to actually have some problems where we can actually use different means and modes. Now, I'm also going to say that you know what, StatsCrunch to me is way more is easier to use than the tables. Remember, you have that option for you to use on your homework as well as any of the tests that you do, but I'm going to do for this video only go to StatsCrunch. If you are interested in needing to do the table, there's still videos over on the DC3 website that where Mrs. Groover goes ahead and does both of them. But I'm going to go ahead and jump in and we're going to go ahead and just use, and I'll have the StatsCrunch that we're going to use and to solve the problems that we have. So the first thing I need to cover is going to be our conversion formula, because remember I just said that our standard deviation was going to, and our mean are not going to be those the amounts of 0 and 1. And so we will have a z conversion formula. And so with this is going to be the x, the value that you're looking for, minus the mean, all divided by your standard deviation. Now, just like in chapter 3, we are going to round those z-scores to 2 decimal places. And if you remember too, we were also discussing the left and right. So you're going to have to decide which part of the area that you're going to be covering and what they're asking for. So let's just jump into the first problem. Okay, so I'm going to give you the ability to read this, but let's go ahead and start with the example number 1. It says, what proportion of men taller than 72 inches height requirement for shower heads? The heights of men are normally distributed with a mean of 68.6, and I'm going to underline that with a standard deviation of 2.8. Again, that's going to be another create where we have the mean, and this is going to be the standard deviation. And then find the percentage of men who are going to be taller than the shower head at 72 inches. And so the norm distribution curve that you're looking at has a mean that's listed here at 68.6. And then also then the 72 inches is going to fall then to the right of that mean. And what we're going to do is we're going to go back to our StatsCrunch. So let me go ahead and shut this down. Let me remind you, in order to get to that norm calculator, go to calculators, and then you're going to come over to the norm, and then it'll pop up your norm calculator. And so I've got to change mine is set at mean of 0 and a standard deviation of 1. So I know that I'm going to go ahead and substitute those numbers back in. So I have the 68.6, and then I'm going to have a standard deviation of 2.8. So now I have to change those. Now, if I'm given then that find the percentage of the men who are taller than the shower head of 72 inches. So remember, this is going to be the section where I'll put my percentages. So that's actually what I'm going to find when I hit my compute. But I've got to go ahead and put the values in here. And notice I have a less than from the time before. So I want those that are greater than 72 inches. So I'm going to go ahead and put 72, and then I'm going to ask it to compute. Notice that it does shade in my norm distribution curve, and again having a mean of 68.6. You could see that that's kind of right where it falls. And then obviously then I'm looking for the shaded area that's going to be to the right of 72, which gives me a value of 11 or 0.1123. And remember that 0.1123 then is going to be then the same as your percentage. So that would be then 11.23%. Going on to the next one. Okay, we're going to not use the table. Let me go ahead. This is the page that I'm skipping is talking about how you use the table to find that. And so we're going to go ahead and not do those problems. Okay, the next one I'm going to do is where we're going to be given the opposite. We're going to be actually looking for the X value. So let's go ahead and jump into the problem. It says that when designing equipment, one common criteria is used to design accommodations for 95% of the population. We have seen that only 46 of the women satisfy the height requirements for the U.S. Air Force pilots. What would be the maximum acceptable height? And again, I'm going to underline height because that's going to be my X value that I'm going to look for of the women if the requirements were allowed were to allow the shortest 95% of the women to be pilots. That is the 95th percentile. Now we know that since this is the percentile, we're okay. Then it says assume that the heights of the women are normally distributed with a mean of 63.7. So I'm going to put a mean right here. So we're going to plot that in. And we also have a standard deviation. So here's my sigma. So my standard deviation is going to be 2.9. In addition to the maximum allowance for height, should there also be a minimum height requirement, and then why? So let's go ahead and do this problem. So we need to find, first of all, the amount that will allow us to be at the 95th percentile. So in order for me to do this, I'm going to go ahead and plug in those amounts into my calculator. So it's 68 or 63.7. I'm going to have a standard deviation of 2.9. And again, my probability now is going to be that it's going to be 0.95. And I also want to say, because they're saying we want to know where that amount, I'm just going to go ahead and keep my greater than sign, and I'm asking it to compute. So in this case, if I were to change that to less than compute 5. So I'm going to say that I want the values, anyone that's going to be, they want to find out who is going to fall within from 0 to the 95th percentile or 90. And that means that I'm going to have those values for X that are less than that. And that means that all the values of 68.47 inches, I assume it's inches, would fall into those categories. So my answer for X is the 68.47. Now, keep in mind over here on my work, this is again the formula that we could also use. And then by looking for our z-score, you can look up your z-score. And again, I'm not going to go through that because if you want to see how that's done, grab Mrs. Gruber's formula.